right, today you're going to do the opposite of the distributive property, which is factoring, which we've been doing a lot of factoring, but this is slightly different. Like this problem right here, there is no c value. It's ax squared plus bx and then nothing. There's c is equal to 0. So how do you solve a problem when it's like that, when you don't have a c? Well, you can always use the quadratic formula, which is long and not very fun for most people. Or you could try and factor this. You could try and simplify it. You can try and pull the greatest common factor out of both of these terms. In other words, what's the biggest thing that goes into 4x squared and 10x evenly? What's the biggest whole number integer, and what's the biggest value of x? Well, it's 2x. 2x, you could pull a 2 out of a 4. You can divide 4 by 2, and you could divide 10 by 2 and still get a whole number. And you can take an x out of each one of those terms. So what's left in the parenthesis? What's left with 4x squared after you take a 2x out? 2x still. And think about the distributive property. If you had to distribute 2x times 2x, you would get 4x squared. All right, and when you take 2x out of 10, basically when you divide 10x divided by 2x, what are you left with? You're left with 5. All right, so think about, you're thinking backwards here, so it's a little bit tricky. If I were to give you this problem and say distribute that, I think most of you could do that. You would say 2x times 2x is 4x squared, and 2x times 5 is 10x. So you can check your work when you're doing these kind of problems. You can pull out what you think is the greatest common factor and multiply it by what's left, and if you end up with the same thing as when you started, then you did it right. If you end up with something different, you made a mistake somewhere, so you got to go back and check your work and think about what you did. All right, so that's how you would factor this problem to simplify it. The whole thing's still equal to 0. Now for the work today, that's all you have to do. You're done once you factor it. But really, the reason you're factoring it is to try and find the x-intercepts, to try and figure out what makes the left-hand side of this equation equal to 0. Well, we ended up with two things. We ended up with a 2x and a quantity, 2x plus 5. So we have two things being multiplied together. As long as one of those things equals 0, then the whole side equals 0. So this is your zero product rule from yesterday. How would you solve for x here? Well, you would set 2x equal to 0, and you would set the quantity 2x plus 5 equal to 0. Because if either one of those things equals 0, then the whole product equals 0, because 0 times anything is 0. So how do you make 2x equal to 0? You divide 2 to the other side, and 0 divided by 2 is just 0. So if x could be 0 in this problem, if you substitute a 0 into the original equation, 4 times 0 squared plus 10 times 0 is 0 plus 0. That works. So that's one x-intercept in this problem would be 0. Another one, you would subtract 5 to the other side and then divide by 2, and you would get x is equal to negative 5 over 2, or negative 2.5. And if you substitute negative 2.5, which is a little bit more difficult to do in your head, but it works, if you substitute negative 2.5 into the original equation, the left-hand side will equal 0. So both those work. So that's why you factor, because then you don't have to use the quadratic formula or a calculator. You can do this pretty quickly and figure out what your x-intercepts are. But like I said, in tonight's work, all you have to do is above the line. All you have to do is factor it. All you got to do is pull out the greatest common factor, and you're done. All right, the problems could be a little bit trickier. They might look something like this. Now you have three terms that you're trying to factor. So look at the whole numbers first, 3, 24, and 45. What's the biggest number you can think of that goes into all three of those numbers evenly? Well, you start off with 3. That's not too many options. It's either 1 or 3. We're not going to use 1. You don't ever pull out a 1 because then the problem doesn't change. So you try 3. That's our only other option. Does 3 go into 24 and 45 evenly? Yes, it does. So you could pull out a 3. Now, how about your x terms? Is there an x in every term? Yes, there is. There's only one x in 45. There's x squared, basically x times x in the b term. and ax to the third power. There's three x's there, but there's only one with the 45, so you can only take one x out. So we're actually taking out a 3x is the greatest common factor that we can take out from all three of these terms. And now, what would you multiply with 3x to get it to be 3x to the third power? Well, 3 times 1 is 3, so the whole number is just going to be 1, and you don't have to write down the 1 for the whole number when there's a variable after it. So instead of saying 1x squared, because it's x squared, remember when you multiply x's together, you're basically adding a exponent for every x that you have. So x times x squared is x to the third power, but we don't need that 1, so I'm going to get rid of that. So 3x times x squared is 3x to the third power. All right, next, what would you multiply 3x by to get it to be 24x squared? Well, 3 times 8 is 24, and x times x is x squared, so it's 8x. And then finally, what would you multiply 3x by to get it to equal 45x? Well, 3 times 15 is 45, and x times 1. You don't even need to add another x in there. X is just going to be x, so you just multiply it by 15, plus 15. All right, and you can check your work. If you distribute the 3x through, 3x times x squared, right back where you started. 3x times 8x, 24x squared, right back where you started. 3x times 15 is 45x, right back where you started. So we factored it correctly. Now, you're lucky that that's the end of the problem for tonight's homework. Really, you should have to continue on to figure out what the x-intercepts are. Well, you've got two things being multiplied together. One of them can be factored even further. This x squared plus 8x plus 15, now that's our standard quadratic equation. That's ax squared plus bx plus 15. So is there a number that are there two numbers that multiply to give 15 and add to give 8? Yes, 3 and 5. So you would factor that further into 3x times x plus 3 times the quantity x plus 5 is equal to 0. So that is the equation fully factored. And now you could take each of those three terms individually and set them to 0. So you could set 3x equal to 0, you could set x plus 3 equal to 0, and you could set x plus 5 equal to 0. So this is another problem that's actually going to have three x-intercepts. So it's not a parabola, which you can tell because it's x to the third power. If you have x to the third power or fourth power, or any power bigger than 2, or less than 2 for that matter, it's not a parabola. It's got to be x squared. You can have an x squared and an x term, but your biggest x exponent has to be 2 exactly. If not, it's not a parabola. So this one isn't going to be a parabola. This is going to be that squiggly line that I think I showed you yesterday, or maybe it was earlier in this video. But it would look something like that, where you cross the x-axis 3 times. You would actually cross it at 0, -3, and -5, because x equals 0 is the answer to that first problem. X equals -3 is the answer to the first parenthesis, and x equals -5. So you would cross the x-axis at those three places. Those would be your three x-intercepts. That's how you would figure it out in that problem. But like I said, you can stop after the first step above the line in today's work. They just want to know, what is this? What is the greatest common factor? What is the biggest thing that you can pull out of every term that goes into every term evenly? Because that is the first step in solving these problems. They're baby stepping it with you. They just want you to do the first step, but this is what it's going to lead to. So today is just an introduction. It shouldn't be too difficult for you.